Hi there, my name is Gaurav Rishi. Thank you very much for joining in here. And we have an action-packed agenda today. So let me do quick introductions and tell you what we're going to be speaking about today. So like I said, Gaurav, I'm the Vice President of Product Management, and I also look at cloud-native partnerships. And I also have Matt Bader here. So Matt, why don't you introduce yourself?
Sure. So I'm part of Gaurav's team, focused on solutions enablement as part of the Kasten product group. Happy to be here.
All right, now we are both thrilled, and thank you so much. Like I promised, we're going to talk about a lot of interesting things today. We're going to talk about containers and Kubernetes. You'll get a peek under the covers around what it means and why it matters. And then we'll really dive under the key 5 trends that we see in the market today. And we hope that you find it as interesting as we do. So without further ado, let's dive right in. So let's talk about containers and Kubernetes. I'm sure you've heard these words before. Some of you might be experts, some of you might be just starting out in your journey. Our intent here is to make sure that all of us have the same vocabulary out here. So over the next 10 minutes or so, we'll try and dive under the covers, like I said, and talk about what this means. So let's start here, right? What is containerization? I live in the Bay Area, and the Port of Oakland is someplace where I have gone a few different times. Port of Oakland, for those who are not familiar, is where 99% of the containers that come in these ships are handled for Northern California. And, like any other organization and an industry, we come with certain vocabularies around how they define what these containers are. So they talk about, last year there were 2.5 million TEUs, which is essentially 20 equipment units, 20-foot containers is what you should be thinking about, that were transacted. And it's fascinating. When you go to these ports, you will see these containers come up on ships. You'll see these cranes which are orchestrating, moving these containers from the ships onto trucks or onto railroad cars. And it's a busy place. And you don't know what's inside the container, but you probably guess that it's either some electronic equipment, furniture, name it. But it is a busy place. And what containers have done, because of the way that they've been standardized into what I was calling these 20-foot containers, is revolutionize these industry. It's now super simple to be able to get this portability of having content which is inside these containers be transported from place A to place B, and it could be a variety of media, whether it's ships, whether it's railroads, or whether it's trucks that's moving it. And it's a similar thing that we now see as an analog when it comes to software containers, which is what we're going to really be talking about. And it spans across 2 vectors. It's about how people are going ahead and creating software development processes to work in this new containerized environment, and how we go ahead and operate once we have these containers. So that's really the setting. And let's talk a little bit about how we got here. So all of us are probably familiar with the fact that life started with you writing applications on top of an operating system, which is typically closely tied to a hardware. You have specialized hardware depending on if you had applications like maybe video encoding in the past life. Things became a lot more malleable when we started getting into virtualization. And here what you ended up doing was being able to carve a single machine into smaller machines by using hypervisor as an abstraction layer and creating smaller mini computers, if you will, on the same piece of hardware. Now that piece of hardware could be sitting on premises, or you could be running these virtual machines in the cloud itself. But remember, as you see in the picture out here, the various applications that you might have used to have their own operating system bundled with each virtual machine instance that you have out there. And the hypervisor, like I said, abstracted you from that hardware. Now, enter the world of containers. Now, this is truly revolutionary, and you'll probably see the analogs around why we were talking about the shipping context. And in this particular context, what ends up happening is you have, similar to those containers that you saw on the ships, little microservices is the way how your applications are built out. These are small pieces of code, and to contrast it, it's not the big analogs of having microservices versus monoliths that you might have heard of in the leftmost picture out here. So you break up an application into smaller manageable parts. Those are microservices. managed by these little container boxes in that representation. They run on top of what we call a container runtime instance. And all of these applications share an operating system. What that results in is two things. One is you can have an application with these microservices as containers that are far faster in being able to come up and scale down. So you get to use your underlying hardware a lot more efficiently. And then second thing is they also are very portable. Again, like that little ship example I was talking about. And that's represented by that bottom picture that you see out here, which is essentially you could be running these applications now in the public clouds, in your data centers, and now increasingly on the edges, which could be anything from smaller retail stores or floating ships, literally, and so on, where you might have less compute and intermittent network connectivity. So this, again, has quite revolutionized the way that we think about software development. So where does containers fit in with Kubernetes? Now, just like when I was talking about that you had these cranes and you had these operators who were moving content and containers from one place to another, similarly, Kubernetes is that orchestration system in the software world when it comes to container orchestration. Think of this as the next generation distributed operating system. That's at least how I think about it, where it's not only thinking about how do you move containers from one machine or from one deployment location to another. It's also talking about where should you place these loads so that you can get the maximum benefits of eking out the most amount of efficiency and using the hardware under the covers to the best possible scale. It can automatically go ahead and discover all the various services out there and truly scale up your system so that you, as an application developer, are not really worrying about the system setup and physically wiring things around. You just sit back and your applications can scale up and scale down. And those applications, of course, have been created with those little microservices points that I was making about. And we'll talk a lot about that as we go along. So let's talk about Kubernetes in a little more detail. But before we do that, you can ask yourself, why the fuss, right? Why go through this little revolutionary change? And what you see in the subheading out here really sums it up. It's truly about portability, speed, and agility. Now, this is really a common picture that you see with this infinity diagram, but I think it fairly represents this change in the way we think about software development and deployment with DevOps processes. Now, what you're really seeing is developers, and you'll hear this word shift left, but what's really happening is a lot of functions which you used to think are completely native functions, and only the operations team need to be worrying about them, are being incorporated into the development workflow. And that's what you see with the developers on the bottom side, an arrow showing that they do really care about operations too. And on the other hand, the platform teams, these are people who are going ahead and making sure that you have an operational platform that various application teams can go and develop on top of, are also going ahead and helping you create, and they're also transitioning their own roles and becoming SREs or site reliability engineers to make sure that you as an application developer don't have to worry about the nuts and bolts of scaling your application on a day-to-day basis across regions or thinking about what the underlying hardware or storage systems are. But at the same time, giving you the warm fuzzy and the tools to be able to allow you to sort of, for example, protect your application with data resiliency tools, backup tools, and things of that nature. The net result of all of this is you have a new way of not only developing applications like I was showing in the previous slide with containers and microservices, but you also have the way to make your organization a lot more agile. You can go and develop a lot more capabilities in a much shorter time with a lot fewer application developers. And that hits both your competency aspects in a positive way, as well as reduces the cost. So the reasons are fairly obvious, and you don't have to just believe me. You actually can look at some of these numbers which are staring us at the face here. And application developers, for example, have now grown 67% who are using Kubernetes and grown to this massive number of 5.6 million. And they don't seem to be showing signs of stopping. And organizations are taking advantages of these application developers who are now using these capabilities and are moving virtualized services to the cloud. And the inverse point of that is actually just that middle picture I was showing you as you move from monolithic, hardware-centric to virtualization and now to containers, is also indicating that the pure server virtualization market is not growing very fast. So the net result of this is this wave is already here. We internally joke that Kubernetes is the next wave of infrastructure, and I think these numbers really prove that. So let's slip into another gear and talk about the technology behind this and truly talk about what the building blocks of Kubernetes and containers are when we think about these next generation applications. So I'll keep the slide up, and then maybe I'm going to invite my friend Matt, who's the person you really want to listen to, who's going to help us understand what these building blocks and the new vocabulary that this industry comes with actually mean. So just to set the slide up, what you're really looking at is really a simplified, cartoonish-like picture of what a cloud-native application today looks like. So everything inside that dotted line is something of what we would call a cloud-native application. It's running inside a Kubernetes environment, and that's the icon you see on the top right of that helm. What you do see here is an application which has two microservices running out there. That's the left side and the right side, running in two different pods. And we'll talk about what pods means in a few seconds. Now, one of the microservices is connected to some storage system, in this case, through a PVC, which stands for persistent volume claim. We'll talk about that, to a hard drive. And there is a second microservice, which is now connected to some database that you see with the little database icon out there. Now, the two key points I want to make out here is all of these components that make up your new application, first of all, are running in a Kubernetes native environment. That comes with it not only the way you develop the application, but also the way you manage and deploy and scale the organization and the application that goes with it. And the second part of it is that unlike the old worlds where you either had the hardware as the scaling or the operational unit, or the virtual machine as the operational unit, in this new world of Kubernetes, what you need to be thinking about is that dotted line, which is the application, becomes the unit of atomicity when we talk about how you think about scaling up or scaling down or managing in terms of protecting, for example, this entire application. So what do these components mean? What does configuration management mean? What does secrets mean? What does the service mesh concepts mean in this context? Let me invite my friend Matt here. And Matt, why don't you get us a little more educated in terms of what the building blocks are so that we can go ahead and start then getting this elephant in shape?
Yeah, absolutely, Gaurav. Thank you. And we will definitely continue to revisit this concept of what is an application throughout the rest of this webinar. But I think I wanted to start with my own kind of personal why around, why Kubernetes, why has Kubernetes become the force that it is. And I think ultimately it solves the problem of, well, it worked on my machine, right? And going from development environments to staging to production and continuing throughout that life cycle image that you had shown. And I think a big part of how that has come to be is not just the sort of portable nature of containers themselves, but is really the programmatic nature behind everything in Kubernetes. So everything that we're going to cover from a building blocks perspective is ultimately represented by some declarative code. Oftentimes that's in a YAML markup format. So I'm being able to, again, define all of my infrastructure as code or all of my applications as code, and really allowing to dial in that configuration such that, again, it's going to be the same in every one of your environments. So again, as Gaurav mentioned, let's talk through some of these building blocks. And really starting with the pod. So we had introduced the concept of containers. How is a pod any different? A pod is really the Kubernetes construct for a container, although you have the ability to actually run one or more containers as part of a pod. So in this case, let's imagine, you know, our pod or our container in this case is a simple Nginx web server. So most pods, you're going to have a sort of one-to-one relationship between, you know, that declared Kubernetes object and the container image that it's running. So in this case, just a simple web server image. Although there are, you know, other cases where maybe I've got a, you know, what we'll often call a sidecar container, and that's something that, you know, as an example, is responsible for monitoring or logging operations for the primary container itself. But this is again the most sort of important logical building block that allows you to define what containers you're running, what images those are using, and then also, as Gaurav had begun alluding to, the other resources that are being leveraged by these containers. So volumes, so this concept of a persistent volume, which is really just storage being presented to your Kubernetes cluster. And then the persistent volume claim, or PVC, is really what binds a particular volume on disk to a specific pod. Or as we see on the right-hand example here, going back to the, you know, my database connection, if a pod is ephemeral, that is to say, it's stateless. If I were to restart that pod, it would come back up in the exact same state every time. Any custom information I need to inject into this environment, say in this case, it is the IP address of a particular database server I want to connect to and the port. I would do that through a config map, which is again just additional declared information that can be mapped to a pod, so it understands. You know, it's like supplying environment variables at that point. And then similarly, the concept of secrets. If I'm going to authenticate to that database, I might need a username and password or some type of private key. So the platform affords us, you know, an ability to store all of these things and connect them to our pods. Let's move on and talk about how these get deployed on a cluster.
Sure. And now before we did that, so just to tie it with the previous picture, maybe the 2 points I'm taking away from, as you explained, this concept of pods and persistent volume claims, it ties in really well, I thought, with that picture around, you know, the life cycle around DevOps, where as a developer, you know you need a particular type of storage. And so you can put a claim for it to say, I need a storage which has read-write access, I want it to be fast, so I want an SSD, but you don't care about what that underlying storage physically is. That maybe becomes something of the actual late binding that your claim is honored by the platform team, and it might be an actual, let's say, block store if you're running in an Amazon environment, or it might be a physical SSD if you're running on premises, and that can be surfaced up later. So I think this ties in really well into this concept of keeping all of your objects, like we talked about, config, secrets, and so on, which is basically a network compute information in these Kubernetes objects, and then also do this concept of late binding, if you will, so that your DevOps gives you the agility with these building blocks. So I think it's sort of falling in place, but like you said, let's keep going and talk about what deployments mean here in this context.
That's a really great point. It's essentially you're shifting the capabilities left to developers to have more control, more agency in the infrastructure component, but without necessarily thrusting the responsibility on them of having to understand every detail of the underlying hardware infrastructure. It's a really great point. So once we've got this idea of a pod defined, you're typically not going to be deploying just a single pod as a workload on a Kubernetes cluster. you're typically following this microservices model where I've got say a front end, I've got middleware, I've got a back end, maybe I've got a separate logging service. All of these might be comprised into a single deployment that represents your application. So again, this is another YAML markup object in Kubernetes. That this is what's taking advantage of that control loop functionality of Kubernetes, where you are declaring your intended state for the cluster. I've got a deployment of my application where I have 3 copies of my Nginx web server, but if I were to suffer a failure within that cluster and I lose a node that's running one of my Nginx pods, this deployment is what's defining, okay, we need to spin up the 3rd copy of that pod on one of the remaining nodes of the cluster. So this is giving you a lot of what, those of you that come from a virtualization background, which I'm sure is many of you, this same concept of high availability within the environment. And similarly, deployments are also what are going to allow you to roll out changes to that application over time. If I'm introducing a new microservice to the application, as an example, this is what's going to support me being able to do that rolling introduction of these new workloads.
Yeah. No, I think just to tie it back again, I think I touched on the fact that Kubernetes is more than just an orchestration system. And so as we talk about some of the building blocks and capabilities of Kubernetes, deployments being one of them, I think getting this concept of high availability where, again, you get the agility as a developer, you don't have to worry about restarting pods when they die, and they do that for a variety of reasons, truly makes you a lot more productive as an application developer, but also as an operation team member, you don't need to get into the nitty-gritties. A lot of that work is done by the Kubernetes underlying operating system, if I can use that word, for you. So, so with that said, maybe we continue down and talk about stateful sets, which I know is super interesting also.
Yes, yeah, absolutely. So I think the primary difference to understand here is in a deployment. We'll go back to the example I used before, where I'm spinning up 3 what are called replicas of the same pod, so my Nginx web server pod, to the Kubernetes cluster. Those 3 pods are essentially interchangeable. If that node dies and it brings it up on another pod, or another node rather, it's not giving any thought to the individual identity of those pods, because essentially it doesn't have one. However, that type of deployment is not going to be something that's applicable or useful for what we would call a stateful workload. So in this case, let's think about more of a database. So I've got a MySQL database or a Postgres database. That in this case, there are many reasons why I'm going to care about the individual identity of these pods. So if we think about how we support high availability in many databases, I need to ensure that my pods aren't running on the same node as one another. But also from a networking perspective, they require some form of persistent identity, so that if I do suffer some form of failure, that replacement pod is able to come up on an appropriate node, but also being able to perhaps rejoin any type of high availability cluster, database cluster that it may have been part of. So the solution for this within Kubernetes is this concept of a stateful set, which is really, again, another form of deployment that allows for these additional unique identifiers, including, again, relationships with its persistent volume and the claim that it's made to that persistent storage. So again, the key use cases here certainly are workloads like a database.
Yeah. No, I think this is sort of a big change. I know this came along as Kubernetes grew, but this capability I know is used a lot. I know it's dear to our hearts, Matt. But really, the key point to stress again on this particular slide is when you look at the core capabilities of Kubernetes stateful set in this specific example, you don't have to worry about in case things die. You need to persist certain databases and certain state, and that gets tied back to you as an application developer while things might be changing under the covers for you. And that's all taken care of by Kubernetes, and it'll all come together as we talk about, building serious applications, which of course require you to persist state. Think about you writing an application where you have a shopping cart. You obviously might want to make sure that your transactions are not lost just because your underlying pods are sort of coming up or down. So with that said, let's start bringing in this concept around services, which talk about how things come together, because ultimately that's what makes up an application.
Yeah, so services, again, solve one of the other sort of original problems with managing containers absent Kubernetes, which was, again, as I'm dynamically spinning up these pods that might be spanning across many different nodes within a cluster, how can I easily address these things to be able to connect an application to a database, or connecting a web front end to an application. And this is accomplished in Kubernetes through a construct called services. So this handles the dynamic networking that happens underneath the covers as the cluster is spinning up new pods on new nodes, which again do not have any kind of static IP address model, but is fronting to other applications a well understood name with which pods can start talking to one another to start forming larger applications.
Yeah. All right. Now this is great, Matt. So I think maybe now that hopefully we've gone ahead and talked about what containers are, what Kubernetes is, why it matters, some of the key building blocks that make up the Kubernetes ecosystem, let's really talk about what are we seeing in the market, right? What's going on? And all the people who are listening to us, maybe we can share some of the insights. And let's start with trend number one, which is stateful workloads.
Great. So yeah, as when we started talking about pods, I mentioned that they are by nature ephemeral. Kubernetes, from the outset, was sort of built to originally tackle stateless workloads, and I think for some people there is still this misconception out there that Kubernetes is a platform for stateless workloads. But when we look at the development history of the platform itself and how people are using it, it's simply not true. So going all the way back to 2015, from the outset of the platform, you had the ability to add this persistent data volume component to your pods, but we were lacking sort of some of the pieces again to fully support a stateful application. And I think some of the biggest enhancements along this timeline. So if we look at version 1.9 in 2017, that's where we saw the introduction of stateful sets as being generally available that we had just talked about, and at the same time introducing a new standard for storage called the Container Storage Interface, or CSI. And up until this point, storage providers were integrated directly into the Kubernetes code base. These are what are referred to as in-tree storage providers, of which there were a small number at the time, like your major public cloud vendors. but to sort of open the floodgates for all of the other storage vendors in the market to be able to provide a plugin with which people could use their storage in their Kubernetes clusters. This is what this CSI model introduced. And we've seen that grow from 2017 to today. There are now over 100 storage vendors that have production level CSI drivers available. So we've seen a number of these enhancements. Also, the introduction of the operator framework has been another step, sort of past what stateful sets provide. And the idea behind the operator framework is really to provide an easy button for users to consume different stateful workloads on Kubernetes. So not just helping with the deployment of that application, but really a true sort of one-click lifecycle management experience where, again, if I needed to scale out or scale in that application, I need to upgrade that application. The operator framework provides you with a means of automating all of these repetitive tasks that would be likely very similar from, as an example, one Postgres implementation to another. So the addition of these things, as well as within the CSI framework, this concept of volume snapshots, which again has abstracted the ability for storage vendors to provide snapshots of Kubernetes persistent volumes. We'll talk about how that plays a role in Kubernetes backup protection throughout the presentation as well. But you can see here throughout this timeline, we've been building towards this point where for really the last 2+ years, it has been, the platform is highly capable of running and supporting these persistent workloads. But I think the other interesting statistic that goes alongside this is most organizations have only started adopting Kubernetes in earnest in the last 2 years. So they have only been using the platform at a time when you have all of these capabilities to run stateful workloads. And if we go to the next slide, we'll see really some of the most popular workloads on Kubernetes today are in fact stateful workloads. So this is data from, I think it's 10,000 plus Datadog customers covered in the use report linked at the bottom. So this is not survey data. This is actual in-use environmental data, and we can see that in many environments they are using primarily database workloads. So if we look at Postgres, Elasticsearch, MySQL, Mongo, etcd, all our database workloads running on Kubernetes, and a number of these others still have additional stateful components to them as well.
Yeah, no, and maybe just to bring it together in terms of what an application might look like, which has a front end, back end, database tier, and given that databases now are actually one of the most popular workloads on Kubernetes, given all the advancements that Kubernetes itself has made in terms of adding support for things like stateful sets that we talked about. Help us bring it together, Matt. What am I looking at on this particular?
Yeah, so in this particular case, we see some of the components that we covered in previous slides. So on the this is a simple example of kind of a 3-tier or 3 microservice application. You could have an application that's conceivably one monolithic service that's really not the model for Kubernetes, right? We typically see 10, 20 plus microservices comprising an entire app. But in this particular case, we see 2 different deployments, so non sort of stateful tiers of an application for both the front end and sort of that application tier, each leveraging services to be able to communicate with one another. Some config map that might provide configuration data, again, to that stateless app. So the config map itself could actually be considered a form of state for that application. And then on the database tier, we see that we are leveraging a stateful set for that MySQL database, which is storing its data on the cluster in a persistent volume that is, likely fronted by some type of CSI driver to provide that storage. Now, we talked about how pods themselves are distributed by Kubernetes across the entire cluster. So from a data protection perspective, I can't point to, say, any one worker node or any one virtual machine, any one server anywhere that's actually running my entire contiguous application. So we can't depend on legacy data protection solutions to actually properly capture the state of this app. What we need is a solution that's capable of talking to the Kubernetes server itself, so talking directly to the API server to really extract. Again, we talked about how all of these objects are declared as in YAML. So to be able to extract all of those programmatic definitions of these individual objects, and also at the same time being able to capture the data itself that is running on those persistent volumes, and being able to do that again in one sort of consistency window, so I'm capable of reliably restoring this application in another environment, in the same environment, again in a consistent known good configuration. And it's something I, again, simply can't do with a legacy solution.
No, that's right. And so I think, the point I'll make very quickly, and I'm also conscious of the time, so maybe I'll speed us up, is essentially when we think about these cloud native applications that we talked about, I think there are two things. You alluded to it. Not only are databases not only becoming super popular as a workload, there are a few deployment options when it comes to using these databases. So number one, when we look at these cloud native applications, people are using a variety of databases: SQL, NoSQL variants, time series graphs, Mongo, Postgres, etc. But not only are they using a variety of databases for a single application so that they can get the most optimal tools, they also have a few options in Kubernetes in terms of saying, do I use and run the database within my same application or namespace, as the Kubernetes world verbiage is, or do I run the database in a different namespace? Or do I run a managed database, whether it's an Amazon RDS or a Mongo Atlas, or a variety of them, and it continues to grow. The point I'll just make is when it comes to protecting and managing these applications, again, application turns out to be the unit of atomicity, like you were showing in the previous slide, Matt. And then from a pure Kasten by Veeam perspective, our product, the Kasten K10, allows you to choose any one of these options of deploying databases, but we do support all of them. So you're not tied to saying that I will support only a particular database or only a particular deployment pattern, as long as it's a part of your catalog. That is not the approach, because again, just like you had portability as one of the key benefits when we talked about shipping containers and now these cloud native technologies with containers, we want to bring the same thing in here. So let's talk about another interesting trend, which is moving up the stack. What exactly does that mean in the context of Kubernetes and managed services? So Matt, why don't you talk about this?
Yeah, absolutely. So I think early on we saw organizations starting out on the right side of this slide, rolling their own Kubernetes distribution, based off of just open source upstream distribution, and we've seen much more of a transition towards the adoption of managed services. So we see Amazon EKS, Azure AKS, Google Cloud GKE represented there, and we'll touch a little bit more on the why, as well as platform as a service distributions as well. So VMware's Tanzu, Red Hat OpenShift, and SUSE Rancher in the center, and then also starting to see managed or hosted offerings for things like Tanzu or OpenShift available in the public cloud as well. So you've got Azure, Red Hat OpenShift, or Arrow, or Red Hat OpenShift on AWS available as well.
So I think the point you're making here is really important, Matt, which is essentially, while Kubernetes itself is just about 7 years old or young, like I would like to say, there are many distributions of Kubernetes available, and I think you have different flavors of that. And different vendors, whether they're public cloud providers or whether they're people who are starting off from the on-premises side, give you this rich set of options. And managed services, of course, try and get you that easy button where you might sort of trade off, deep configuration with something that's easy to sort of get up and deploying. So maybe what are you seeing in the market when it comes to managed services?
Yeah, absolutely. So what you just touched on, the driving force behind adoption of managed services is that easy button to get up and running. I'm not sort of responsible for the underlying infrastructure or control plane. So it's again just reducing sort of operational friction that I might have in order to adopt Kubernetes. And this is something, again, from a Datadog report we saw published this past year, that over 90% of their Kubernetes users are leveraging some form of public cloud managed Kubernetes, whether, again, that's AKS, GKE, or EKS. And it really is, it's giving you that focus on the applications themselves rather than, again, managing that underlying infrastructure.
Yeah, I think maybe the market really does want simplicity is the key point here, which maybe again is highlighted in this context.
Yeah, and we see that, we obviously see that again on the platform as a service side, going above and beyond just providing some infrastructure management simplicity, but really starting to provide a more opinionated stack that's even more focused on, what should that developer workflow actually look like, and providing additional tools with respect to security or networking or code management out of the box that you might not see with just a typical managed services offering.
Yeah. No, I think the only point I'll make on the slide is, OpenShift, which of course is the Red Hat's distribution of Kubernetes, brings the benefits that you highlight on the right, but then those are the benefits which we, as for example, Kasten, bring to our customers too. So we are deeply integrated into OpenShift, so you get the benefits of having that secure operating system and workflow. We are integrated into the operator hub, so there is a single-click deploy option. We have source level scanning going on, so we know our images are secure in that context. And from a deployment perspective, you can obviously run Kasten on top of OpenShift on premises, even in an air-gapped environment, or you can have the managed versions of OpenShift, which is what you're pointing out, which is ARO as your Red Hat OpenShift, or ROSA, which is Red Hat OpenShift on top of AWS, also as supported options. So again, diversity of choice, but also to make sure that it keep it simple as we bring that along. So maybe you can talk about what this means in the context of VMware and Tanzu.
Yeah, absolutely. So I think, again, another interesting choice for Kubernetes adoption. There's likely a great many of you joining the webinar today that have existing vSphere-based environments, and this is an area that VMware has certainly invested very heavily in to provide a path for integrating Kubernetes services, whether that's directly onto the hypervisor, or again, the ability to easily sort of deploy and manage a VMware stamped distribution of Kubernetes running on top of their hypervisor, and really some interesting integration points with other vSphere services. So you've got NSX from a networking perspective, you've got a host of different VMware storage technologies like vSAN and vVols that can be integrated into the Tanzu solutions. But for, again, for these customers, you still need a dedicated solution for backing up those Kubernetes workloads, and K10 really can provide a best of breed solution here and follow sort of more of our traditional storage target paths of backing up pods or applications running on VMware Tanzu to object storage, but also for those existing Veeam customers, they're able to leverage some of the investments they've already made and take advantage of their VBR infrastructure to store those backups as well.
Yeah, no, I think this is a super important point, and I think Kasten and Kasten by Veeam in particular is in a unique position to meet you where you might be today and help you sort of transition as you grow the number of Kubernetes applications and cloud native workloads. So on one hand, what you see on the left-hand side, by the way, the slide I remember came out from a joint talk I'd done at VMworld before it was rebranded to VM Explorer. So not only does Kasten K10 have a rich history of working with VMware in the context of Kubernetes with these deep integrations where the storage layer, for example, the cloud native storage layer that VMware has made Kubernetes friendly, but also we are helping you get that bridge, like Matt pointed out, through your existing investments with Veeam backup and replication. So you can continue to use your storage servers, etc., where you might today have tons of your VM workloads protected, also now be able to go ahead and store some of your Kubernetes workloads in this particular environment, in addition to, of course, leveraging object storage. So I think great to have that continuity. And the broader point I'll make, this is a little bit of an eye chart, but an important one. And the point I'll make out here is that freedom of choice, while keeping that simplicity, is super important. One data point which we didn't show you, but is also important, is most organizations have deployments which span across these distributions. I think we'll talk a little bit about what hybrid and multi-cloud means, but essentially, effectively, you need to make sure that you're not getting tied to a particular Kubernetes distribution or to a particular storage vendor or to a particular database. So while keeping that secure layer of encryption and making sure that you have things related to security that we'll also touch on, you have that independence of moving these applications around, or making sure that you might have certain applications running in environment A and some applications running in environment B for a variety of reasons, whether those are regulatory or business optimization or maybe historic. So that's what is really important, especially when it comes to making sure that you're protecting your applications in the context of data protection and backup and recovery. So that's something obviously Kasten K10 provides really well. So with that said, I think it's also a good key off point to talk about hybrid and multi-cloud, which is trend number 3. So I'll let you talk about this one too, Matt.
Yeah, great. Great point around the transition there. So we'll start with a couple of key definitions, because I think these are two almost trendy phrases that can get tossed around quite a bit. So if we build out, the first one. So hybrid cloud is referring to an operating environment that is typically spanning, your privately controlled or on-premises data center and some form of public cloud. But also is likely going to include your remote or edge sites as well. So you've got a lot of thought that goes in here about placing workloads in the right operating environment based on really their technical and economic requirements. And then on the multi-cloud side, that's typically referring to an operating environment where I am consuming services from multiple different cloud vendors. So logically, if we talk about hybrid multi-cloud, it really is this idea of leveraging both multiple public cloud providers as well as that flexibility of being able to move across my own environment. And if we move to the next slide, we can really focus a little bit on the why behind this, right? So the numbers kind of jump off the screen. This is arguably this could be the number one trend of people wanting to move towards this operating model introducing new public cloud providers, or again, strongly agreeing that this is a necessary strategy to meet their business goals. And I think it comes from a variety of places, right? It's obviously about diversifying your risk. It's about improving your ability to scale. It gives you more options to match the environment with the requirements for an application. But I think that honestly, the biggest one from a business perspective is about creating leverage, right? I'm avoiding any kind of Hotel California situation where I am stuck in any one data center, whether that be my own or a public cloud provider. And Kubernetes, I think, has introduced the promise of being able to really enable this kind of model, giving you that abstraction layer of your applications between these different environments. But it's not always that easy, right? So if we take a look at the next slide, I think what we'll see here is again, it's not just a matter of moving my declarative application code, let's say from Amazon to Google back to on premises. I've really got to overcome, if we think about that earlier example of our multi-tier application, I have to overcome this data gravity problem of my apps as well. So to be able to move from one environment to the other, whether that's to take advantage of some business opportunity or to meet any other requirement, I need to be able to move not just that application metadata, but obviously a consistent snapshot or backup of the application data itself. So this is a use case above and beyond just what we think about of typical backup and restore, where Kasten K10 really shines in being able to move between these different environments. And I think one of the key things that we deliver, key features we deliver in this respect is regarding application transforms. So especially when we're talking about moving between different distributions or different storage platforms, there might be parts of my deployment or my stateful set, let's say, that are referencing the storage that's being used, or referencing the number of replicas of an application I might need to run in this environment, that I might need to change those things as a result of that migration, so it behaves the way I want or desire in this target environment. And that again is something that Kasten K10 delivers, and isn't just necessarily tied to migrations. This is a functionality that gets used by our customers every single day to support use cases within a cluster, where I'm simply evaluating the upgrade of an application. Does that break something? Can I easily restore my app to a known good environment? Or taking advantage from a cloning perspective in order to spin up production data copies of apps in test or development environments.
Yep, no, absolutely. I think this truly keeps that promise that Kubernetes brought in with saying that you have portability to be actually true, and that's where we hide the complexity. So let me talk about trend number 4, and he put it as security, security, security. I call it security everywhere. And this again could have been trend number 1, actually. So, when we really look at the problems, they're numerous that we all as organizations face in the context of this increased threat vectors, right? Kubernetes, of course, the way it's architected brings with it its own unique challenges. And it could be problems that span across the fact that it's still a newer technology. And so people are not completely educated in terms of going ahead and making sure that the kind of components that they're using, the open source images that they're bringing about, could be a threat source. You don't necessarily have mature processes when it comes to having this explosion of microservices that you might see observed correctly so that you can not only look at the north-south traffic, but also the east-west traffic, and is a microservice 1 authorized to talk to microservice 2, and if it doesn't, are you observing and warning and taking corrective actions about that? And also, I think finally it's listed as the last point, but is definitely the key headlines around the world today around ransomware. I mean, that is something where you might have all the best tools in place as far as securing your development as well as your operational processes. However, this is a little bit of a cat and mouse game, and we do see people getting attacked with ransomware with increasing frequency, and there are enough statistics around it. And you need to make sure that you have the right ransomware recovery places and tools in place to work in this Kubernetes environment. So that is truly another important point to keep in mind when you think about this growing list of applications that are coming in production with Kubernetes, and hence you need to also protect them. So, again, we won't dwell too much on the numbers, but suffice to say that this truly is a here and now problem. You need to secure them at deployment time as well as at runtime, and you need to make sure that you've got the right tools in place. So the one which I would obviously like to highlight here is this concept of ransomware recovery, because things do slip through, like I pointed out. And so one of the unique things which Kasten was the first to bring to the market in context of Kubernetes ransomware recovery is this point around immutability. So not only are your backups authorized to be sent out to a variety of different types of storage systems, whether those were your legacy investments like you talked about, or new or object storage systems, we can also take advantage of the right ones, read many or immutability support on some of these object storage vendors facilities, so that you can make sure that these backups remain secure. So whether it's because of fat thumbing or somebody maliciously trying to go and delete a solution which should have been archived or a backup that should have been archived, will fail because we use immutability. Not only that, if somebody is trying to go ahead and mess around with your immutable backups, we actually also send out a warning so you know that maybe an attack is in place, and we send it out to the right set of tools. In addition to doing that, we actually have started setting up an interesting set of policies where we're trying to shift what is decidedly in the old world a day-to task of making sure that your applications are protected and your backup DR policies are in place, something that also shifts left and you think about earlier in your life cycle. And to talk about that, Matt, maybe I'll ask you to talk about what do these data protection guardrails mean, and how does this fit into the new scheme of things?
Yeah, absolutely. So this goes right back to what you were saying about how do we shift capability left to developers without having to shift an inordinate amount of responsibility concerning data protection. So these are sort of two different use cases here that we can pursue a policy as code solution to what otherwise is often a human problem of misconfiguration. So the first one on the left is leveraging the authorization hub of Kubernetes. That's this ability to integrate some type of admission controller, and like anything in Kubernetes, this is a plug-in based model. You've got options where we can apply policies to that admissions controller to say, okay, as part of my deployment or as part of my stateful set that defines this application, based on some label that's applied, I need to ensure that this deployment also has an associated K10 data protection policy. I want to make sure that it's set up for hourly snapshots, that it has 6-year retention, that it's storing to an immutable location, and we can do that at runtime to say, okay, either it doesn't meet these requirements, reject the deployment or upgrade of this application, or actually fix on the fly, hey, this was only set to retain for 3 years, the policy is 6, we don't want to reject this, we're actually just going to, on the fly, fix that deployment and start running it on the cluster. So that's the runtime use case. There's also from a GitOps perspective, you could do something similar where at the time of code check-in, for an application, for the infrastructure as code that defines that app, also scanning those exact same type of files to again look for, do we have a policy defined? Does it meet our specific requirements? So I think the word guardrails is very applicable in this case to how we're leveraging policy as code to make security easier for our users.
Yep. No, I think this one scales security and truly shifts things left. So I think this is an extremely important trend to watch, and I think a really powerful one as it takes place. So I know we have only a few minutes, so let's get into something which is top of mind for a lot of organizations, and that's talent. So Matt, again, I think this is something which I'm going to let you drive very quickly.
Yeah, absolutely. So this is an area that we hear from our own customers and prospects every single day. What is their biggest barrier to entry when it comes to really moving Kubernetes into production? Is lack of skills or lack of time. And I'll with respect to data protection, we often hear from people pursuing open source solutions to develop their own solution to provide data protection in their Kubernetes environment, and this is something that again could take years effectively to deliver on the monitoring capabilities, or say a self-service UI, or certainly enterprise support, right? What happens when that one person I have developing this solution, their talent is so in demand, they found themselves with a better job offer the next day? Really being able to focus on, bringing on board enterprise solutions in the same way that we're seeing, managed services and PaaS solutions make it easier for organizations to adopt Kubernetes. I think across the board, a focus on where you need to buy versus build is very critical, and it's largely informed by again this talent shortage, in addition to obviously taking the time out of the work week to better train the people that we have today.
Yeah, no, I think it's about putting the right investments in the right place, and I think that was really one of the reasons that led to the formation of Kasten, even as a startup. And truly, this problem is a here and now issue, and to work at enterprise scale, like you pointed out, giving you that diversity of choice, but backup is your last line of defense. And so to be able to do it where it's super easy to use, I think simplicity and scaling that is sort of number one for us. And really the point I'll make out here is Kasten 10 by Veeam, it just works, right? You go to a marketplace, or you have a single line help command or a single click install. It installs almost immediately, automatically discovers all of the applications running in your clusters. You can have policies which define how often you want these applications to be protected, where they should be archived, if they should be immutable. And then also gives you this role-based access control so that the right teams can go ahead and look at their own applications, and the right roles can be configured so that they can go and recover them or parts of those applications when need be. And doing all of this in the context of the Kubernetes environment and not force-fitting it into something which was a legacy environment is super critical for you. And so it takes a lot of time and effort, which obviously we as a company have done. And so, you want to avoid the pitfalls of going ahead and starting with your do-it-yourself type component solutions, because we do have customers who have run into either scale problems or security issues, and or just realizing that when you do get by ransomware, you might have been able to do backups, but your backup is only as good as your recovery, and you don't have runbooks for that. Or maybe they take too long, or maybe there are only snippets of backed up components that you have. And so those are all important things to keep in mind. That's why you want to invest in the right set of tools. And must be a one part of it.
Just to interject momentarily there too, if the issue is I've got a limited pool of talent, wouldn't, you know, what else could those people be working on, right? If they weren't trying to solve this problem of how do I protect all of this? If I was able to give you, you know, a ready-made solution for it, what else could those people actually be working on that are hopefully going to be driving, you know, your own bottom line?
Yeah, no, that's a great point. Don't reinvent the wheel and maximize your return on investment. So absolutely. So Kasten K10, I think this is just a snippet of customer case studies and successes that you can read about. But the point is, it's widely deployed across a variety of industries, across geographies, and you know, it's problems where we have gone ahead and solved not only just backup and disaster recovery, but also about application mobility that Matt touched on. So I would definitely encourage you to not only go there, but also learn more about Kubernetes. I know we spent a lot of time in the beginning to get you a little more insights into the building blocks of Kubernetes, but you can actually get and do this yourself. There are labs, and I would encourage you to go to learning.kasten.io, and it's super simple to get started and go through these labs on your own. You don't even need to install anything yourself. So try that out, or better still, you can actually also go out and, like I said, in a few minutes, try out Kasten K10 itself. And here's a QR code, and you know, scan this and get started. So let me take this opportunity to thank you again for joining us. Obviously, we are open for questions, but thank you for attending this, and we really do look forward to hearing from you.